Hello, welcome to SCP Online Workshop. I'm Alex. The topic of my video is mitigating risks in TBM tunnel construction. Listen to vibrations. This video will present how we observe vibration data, also called seismic data in the tunnel, to predict risks in front. So let's start. For the TBM tunnel look ahead, as the existence of TBM machine, we have some limitations and requirements when designing a look ahead system. At first, the metallic TBM's disturbance limits the use of electromagnetic wave to detect. And in the TBM tunnel, the tunnel lining with segment rings behind TBM is built just after the mining, so we need a method to be non-destructive to the build terrain. And thirdly, as a limitation of explosive sources in the urban areas, we can't use any explosive sources. And at last, our whole data observing progress should not disturb the tunneling progress. We need a very fast and easy way to get data. So in this case, we apply the seismic wave method to predict obstacles in front. By activating seismic waves and receiving the reflected back waves from the obstacles using geophones in the tunnel, we can get real-time monitoring of the geological condition in front. We only need 3 to 4 people to collect data in the tunnel each time. We leave our equipment in the resting room in the tunnel, and we need to move those instruments to the acquisition point. The method of using a hammer for activating seismic wave is called active method. Firstly, we deployed our geophone on one side of the tunnel and connect all the lines to the computer. And then we use the sledgehammer to activate the seismic waves. Here we can see the one-sided seismic profiles for quality control. For one-sided data observation and imaging, we only need less than 25 minutes. To get more reliable data and reduce the influence of the surrounding layer on one side of the tunnel, we need to do a two-sided observation. We repeated the whole deploying progress on the other side of the tunnel and link the two control boxes together to get vibration data from both sides. To get a higher signal-to-noise ratio of the data, we need a multiple shot activation and stacking data together. Unlike the tunnel seismic prediction method, which is known as TSP using explosive sources, our approach will not destroy the tunnel wall and cause the minimum disturbance to the surrounding soil. So we also collected the vibration signal from the working TBM, which is called passive seismic data. In the passive data observation, the working TBM works as a source rather than activating vibration manually. We can hear from this video that the noises when the TBM is working is very noisy, so working TBM can give us stronger vibrations, getting a longer detection range. We finished our experiment after another 45 minutes passive data observation. The whole data observation and the processing only needs less than 2 hours. After the demobilization and moving instrument back to the resting room, we finished 1 day's experiment. The whole process only needs less than 3 hours. Here we show the prediction results from active and passive data. We can predict 3 obstacles in this area. Based on boreholes and the construction map, we can know these 3 reflections are coming from the foundation of the construction and the soft to hard rock interface. We can get a more exact location of these obstacles and adjust the mining progress based on this information. Thanks for watching my video. If you're interested in my topic, please free to contact me. Thank you.